Now we'll solve problems related to dual. We'll take one example on converting maximization to primal. In primal it is maximization, and when it becomes dual it becomes minimization. Similarly, if the primal is minimization, then the dual will be maximization. As earlier we have discussed, there is an equally important side of the problem, which we call that as dual. Now we'll take a problem and see. It is like, write the dual for the following. The objective function maximize z is equal to 8x1 plus 15x2. This is the objective function, and subject to constraints, subject to constraints are given as below. 2x1 plus 3x2 is less than or equal to 40, and 1.5 x1 plus 2x2 should be less than or equal to 60, and the other constant is 0.75 x1 plus 0.5 x2 should be greater than or equal to 25. However, while we have to write, okay, there are also non-negativity restrictions are there, where x1 and x2 are non-negativity restrictions. This is the problem, non-negativity restrictions. Now we'll solve this. So here what we have to, in any maximization problem, if we have to convert that into dual, what we should ensure or what we should see is all the constants given should be in the form of less than or equal to. If you will see, 2x1 plus 3x2 is less than or equal to 40, that is okay. Then 1.5x1 plus 2x2 is less than or equal to, that is also okay. But the third constant what we have seen, this 0.75x1 plus 0.5x2 is greater than or equal to 0.25. So what we should do to convert that into equation? So here we will write, to convert any primal of maximization problem, we should have all the constraints in less than or equal to form. But we see the third constraint is in greater than or equal to form. So we have to convert that equation into less than or equal to form. Okay. This we can write it. This we can do by multiplying the equation by -1. So how we are going to write? -1 into 0.75 x1 plus 0.5 x2 is equal to -1 into -1 into 25. So now this equation can be converted. Sorry, mistake. Ikkada idi enda equal to okay. Is now idendi వస్తుందా ఇది equal to మళ్ళీ మిస్టేక్ అయింది. Now this should be greater than or equal to -1 into 25. Then this equation becomes -0.75 x1 minus 0.5 x2 is less than or equal to -25. This is how we have converted this into equation. Now we'll write primal. Now we will write dual, not primal. We'll write dual for given primal. So how we are going to write this? That is, so in the primal problem, what we have created was with x1 and x2 variables. Here in dual we'll use y1, y2, those kind of things. So here now dual is given by so earlier we had maximization, so obviously dual should be in minimization. So we'll write minimize z of y. That means y here indicates it is dual. That is 40 y1 plus 60 y2 minus 25 y3. So when we are writing this, what we need to understand is this 40, 60 and minus 25 were from the constraints. We should remember this when we are writing this dual, that the objective function will come from the constant, the coefficients of constraints. Then here also the subject to constraints. What are those constraints? Constraints will come from the given constraints only. That is 2y1 plus 1.5 y2 minus 0.75 y3. And where it was lesser than or equal to, but now we'll write it is greater than or equal to 8. This 8 was from the objective function, coefficient of objective function. Then next constraint is 3y1 plus 2y2 minus 0.5 y3 is greater than or equal to 15. So what we need to observe here is these coefficients. This equation has come from, this is a coefficient 2x1, this was 3x1, this was 0.75x1. Here this is 3y1, then 3x1 was there, 3x2 was there, 2x2 was there, 0.5 x3 was, x2 was there. So these are all x2 coefficients, these are x1 coefficients. So now as usual we will write subject, what we write here is where y1 comma y2 and y3 are non-negativity restrictions. That means they cannot have any negative values. So write like this: y1 should be greater than or equal to 0, y2 should be greater than or equal to 0, and y3 should be greater than or equal to 0. Or we can also write like this: y1 comma y2 and y3 should be greater than or equal to 0. This is how we will write the dual for maximization problem.